That's Hi, hello. Hi, hello. We'll just wait for everyone to join the call first. Okay, hi everyone. I'm Tyson. And before we start our AMF crash course, uh, sorry, we'll be going through this deck of slides for you just to know what you're gonna learn or you're gonna get from us at Dojo. So who we are? We are Singapore's first fully online tuition center, and as you can see on the right, we've got EMath, AMath, Chem Physics, as well as biology classes. And uh, with me, I have other tutors as well who are doing these other subjects that I have mentioned. And most of us, we are waiting to go to university or are already in uni. So some of us are in Cambridge, NUS. So at Dojo, we are trying to inculcate like a culture of just like an older sibling helping you all with your work instead of like a teacher. So any questions or whatever queries you have, you can always text me or just text in the chat. The people on YouTube also watching. I'm also checking the YouTube chat, so y'all can text there as well. Okay, just for like the funds of this lah. Uh, y'all wanna guess how old? Y'all wanna guess how old I am before we move on to the next slide? Y'all can just like comment in the you can comment in the comment section lah. Then we'll see who. Okay, so 18, 20, 21, 22. Okay, so oh, Amelia with 69. Okay, so for myself, I'm actually 20 this year. I am currently still in NS. I am going to be finishing my NS very soon lah, in November, and I will be entering uni next year at NUS. So on to our next resources. All of our learning resources will be distributed to you online if you join us. And as a student, you get worksheets and notes from us. You get cheat sheets, as you can see on the right here. And of course, whenever you need help, you can always text us on WhatsApp or and we'll try to respond you as quickly as we can. And also, of course, our classes are recorded, so you can always let us know and it will be recorded and sent to you. So just our results are at Dojo. Actually, most of our students do achieve an A1 at their O levels, and they go to schools like RI, EJ, Hwa Chong, and AC. And then on the right, you can see some testimonials by our students lah. So our results also show that the teachers are doing their work and we help you prepare the best you can for O levels. And of course, when you go into the exam, you are less stressed because we have exposed you to as many questions as we can. And then just some text lah between us and our students. It just show like the relationship that we have with our students are actually very chill. You know, the students can always just text us and we'll just reply to y'all lah. So y'all can also just address me as Tyson. Y'all don't have to call me sir or teacher lah. Tyson or Cher works as well. And this is our schedule. So for those that are interested also in taking other classes, we will send this to you as well so that you can see. But Saturday will be AMF from 10 a.m. to 12 p.m. for those that are interested in signing up. And now we can go to the prices of our lessons. So for just at $60, you I'm sure most of y'all will be quite surprised, but because of our online setting, we choose to make our lessons very affordable. And this would be good also for for your parents who are paying for your tuition. And then sorry. So as a student with us, you get a week, of course, you get worksheets, you get cheat sheets, support that we will provide for you, and as well as we'll give you mini quizzes to prepare you for your examinations in school and eventually your O levels. And okay lah. So this is just the QR code if you can scan, and this is just a picture of me, from like 2 years ago. Okay, so with that being said, we'll start our notes for today. We'll go through we'll go through the trigonometry notes first, and then later on we'll go through the worksheet. So give you some time, take out the notes, and then just be ready. So most of the questions that I'm going to be going through with you are mainly examination questions that always come up in exams, and as well as questions that your schools don't usually they don't usually show you or expose you to you. So this is where tuition helps you to see questions that you won't see, and when it comes out during your exams, you all won't be stuck lah. So we'll go through the content of today. So we'll have trigonometric ratios, and then graphs, followed by your equation and identities, and lastly your R formula. So I'm sure most of you have already covered these in school. So anything that you're not sure of, you want to clarify, you can just text in the chat, and I'll be monitoring. If I do not if I do not address your question in the chat, you can unmute yourself and let me know. So we'll start with trigonometric ratios. This is basically the fundamentals of your ratios. And I'm sure you have also learned about this in EMath. So what you have learned in EMath can also be applied to AMath. But what you learn in AMath is not usually applicable to EMath. So your fundamentals in trigonometry for EMath should be good so that you can better understand AMath trigonometry. So we start with the basics. Sorry. Okay, wait. I see someone who needs the notes. Let me send it again. Okay, those who need the notes, I've already sent it. So as I was saying, trigonometric ratios, the basics of everything. We have your three: sine, cosine, and tangent. So for sine, it is very quickly, it is your opposite over hypotenuse. For cosine, it is your adjacent over hypotenuse. And then for tangent, it will be your opposite over adjacent. So we go to your reciprocal ratios, right? Just a very quick one. Fun fact, easier way for you to memorize like reciprocal ratios is to look at the third letter of each ratio that's presented to you. Because last time, also when I was doing AMath, I also felt that like I'll be a bit confused, especially when I see cosecant and secant, and then I'll be thinking in the exams like, oh crap, I can't remember. Like sometimes I'm a bit like doubtful of what the ratio actually means. So just an example for you, can see over here. So for cosecant, the third letter S, which reflects with sine. So this also is the same for secant. Your third letter, C, coincides with cosine. So this is just a very simple way of remembering the reciprocal ratios, and I hope it helps you all. And then obviously for cotangent, very obvious, 1 over tangent. So also another thing for everyone, just another thing for everyone to take note, a simple conversion from radians to degrees. So sometimes in the exams, they may ask you to convert from radian to degree, right? And they may want you to leave it in its exact form, so you don't use your calculator. So you use this formula, pi radian equals to 180 degrees. So what do I mean? How do I convert this from degrees to radian or radian to degree? Let's say, for example, I want to get, so I write the equation pi radians equals to 180 degrees, right? Let's say I want to convert this into 1 degree. All I need to do, just divide by 1. And then same for the other side as well. Just like that. So this basically works with any degree that you have to convert into. Let's say you want to convert it into 5 degrees, all you have to do multiply by 5. And then on the other side, multiply by 5 as well. 5 pi over 180. Just like that. So it's just a very simple way of converting your radian to degree. And in case if anyone didn't know about it, any questions, please ask me. I will be checking both chats. So sometimes I will I'll stop myself from talking to see the chats to make sure that you are with me. Okay, no questions so far. We'll move on. So we come to your principal values as well as your special angles. For these two tables that I've already presented to everyone here, this is for you to mainly memorize, because especially for your special angles, this table is not provided to you in the exams. So it's something that you have to memorize on your own. And there's a little trick which I'll teach you. So we start with the principal values first. The principal values of these ratios that we're working with, sine, cosine, tangent, these are always true. So I want you to focus on the brackets that I have indicated for sine, as well as the bracket for tangent. So I intentionally put it this way because this bracket in AMAth means inclusive. So if I were to write it in another way, it would be from negative pi over 2 as well as theta pi over 2, just like that. So remember that this includes the value negative 90 as well as 90, whereas for the other bracket for tangent, 90 and negative 90 is not inclusive. So just for y'all to remember, sometimes in the questions they can ask like, what is the principal range of sine inverse? All you need to do, just write these values down. And same for the others as well. So for your domains for sine and cosine, just make sure that these two values are the same. Whereas for tangent is from inclusive negative infinity to infinity. Okay, now we go to the special angles. So this is I feel like this is what many people, sorry. So for special angles, this is the part where many students struggle to memorize the values of sine, cosine, and tangent. So usually what I do in exams, I'll go into right after the paper starts, I can write this table down first, sine, cosine, and tangent. And then if you can see, right, actually, the values are going up in an increasing order. So 0, 1, 2, 3, 4. So every time you go into the examination hall, you can do just write it 0, 1, 2, 3, 4. Of course, with a square root on top. And everything below the fraction is always 2. So for sine is from 0 to 4 in an increasing fashion. And then for cosine is from 4 decreasing down to 0. So that's how I memorize it. And I'll never get it wrong. So you can see cosine, square root 4, square root 3, square root 2, square root 1, and then square root 0. And then to get the value of tangent, all you need to do, you just take sine of the value of sine over cosine. So in this case, for the first column that we look at, sine, the value of this is 0, whereas the value of this is 1, but 0 divided by 1 is 0. So on and so forth. So for these special angles, just mainly remember that you all have to memorize this by heart when you go in for your exams. Because if you don't remember your special angles properly, sometimes in the questions they may ask for you to use exact form. So that's when you can't use your calculator as well. Okay, so moving on to our quadrants. Okay, sorry, domain range. Okay, so to address Eugene's comment about how domain and range is not taught in AMF, this is just an extra for y'all to know. Good to know. In Sec 4, eventually you will learn about this. So now we talk about our quadrants. And for quadrants, we use the basics. We use the fundamentals. This acronym ASTC. So for the first quadrant, A represents all positive. And then for S, T, and C, the respective quadrants just represents that specific ratio that is positive in it. So for the second quadrant, S, which means sine is positive, and then cosine and tangent are negative. And then for this applies for tangent and the third and fourth quadrant as well. So just to help everyone understand a little bit better, so to find your the value of theta. So for example, now I want to find the value of theta in the first quadrant. Theta is the same value as your basic angle alpha. So alpha will always remain in your first quadrant, and that's also how you find the value of alpha from your first quadrant. Now moving on to the second quadrant, the movement of the quadrants, by the way, is anti-clockwise direction, as you can see from the numbering that I've placed. So to find the value of theta in the second quadrant, since this is the x-axis, right? So to find any value in the second quadrant, this is your theta. This will be 180 minus alpha. Or if it's in radian, then you can do pi minus alpha. So this is for your second quadrant. Your third quadrant, same thing. you do now to find the value of theta, you do 180 plus alpha. And then same for radian as well, 180 plus alpha. Anyone with questions? Okay. So for your last quadrant, which is the fourth quadrant, to find the value of theta, it would be 360 minus alpha, or 2 pi minus alpha. So this ways of finding theta applies when you're dealing with, applies when you're trying to, when your quadrants are going in an anti-clockwise manner. So sometimes your quadrant may start from the negative portion. So earlier I briefed that the first quadrant, your value of theta would be the same as alpha. So like that, theta is equals to alpha. Sometimes you have to start from your fourth quadrant, right? In this case, the value of your alpha is now negative. Since you're going now in a clockwise direction, meaning from the fourth quadrant, third quadrant, second quadrant, and then your first quadrant in this way. So now you may ask, like, how the manipulation of finding theta will work, right? Very simple. All you need to do is just add a negative sign in front of what you're trying to look for. So since you're going the opposite way now, this would be, just add a minus in front, 180, still the same from earlier, minus alpha. And then if you apply the negative sign in, it'll be like that. So this is to find the angle when you are in, when the rotation of your quadrants are going in the opposite direction. And then for the third, now it will be the third quadrant, since if this is your first and then second, this would be negative 180 plus alpha. And then just like that. And then lastly, it would be minus 360 minus alpha. Okay. It's a negative. What number? Okay, Nico, do you mind explaining what do you mean by if it's a negative angle so I can understand your question better? If you can type it. Okay, can. So yeah, any questions, anyone can just text in the group chat. Sorry, in the comments. Okay. Now we move on to trigonometric graphs for sine, cosine, and tangent. So your your trigonometric graphs, they are very standard. If theta is sorry, there's a question. Let me see. Okay, so just for everyone, for clearer understanding for Daya's question, if theta is clockwise in the first quadrant, is it negative alpha? So alpha, right, is your basic angle. So this value will always be positive as a basic angle. But let's say, for example, right, you are working with sine, right? And then your basic angle that you get will always be positive, but the value of theta for sine will be negative. So let's just say the value of alpha is 50 degrees, for example. But when you apply it to the different ratios that you're working with, then the value of theta for sine would be negative. So the value of alpha will always be positive and will always be within 0 to 90. And then afterwards, you have to see your question whether what ratios they give you and what quadrants they're asking for. Okay. So we go back to our graphs. For graphs, your for sine and cosine especially, these are the two graphs that you have to focus on. Not so much on your tangent actually. So because usually your examinations, they will ask you to sketch sine graphs, cosine graphs. And as students like us, we have to understand and also, of course, know the basic shape of a sine graph as well as a cosine graph. So the first graph we see, this is a sine graph. Its basic shape, you can see like that. And the maximum point, which is here, the one I just circled or shaded, that would be your maximum point of 1. As for your minimum, it would be -1. So this is the same for your cosine graph as well, whereby your maximum is 1 and then your minimum -1. Okay, so Seva has a question. When will the quadrants go clockwise? So let's say, for example, in your question, they may ask you to okay, so I'll just go back to this. So your quadrants usually they go in anti-clockwise. They go in an anti-clockwise manner. But let's say for some reason, right, they ask you to go this way, it would usually be like a lead up to this question. So, or when you are, let's say you're doing a question, it'll be part 1, part 2, part 3. Then maybe at part 3, uh, they may ask you what would be like the angle or what would be the value of theta for said ratio. So don't worry too much about when the quadrants go clockwise. So just remember to understand the anti-clockwise version. And it's very rarely that that your quadrants they will ask you like to present it in a clockwise manner lah. Okay, back to the graphs. So the features of sine and cosine, mainly the differences would be the shape. And then also now, I want everyone to also understand what I mean earlier by the special angles that we were talking about earlier. So let's say you forget about like your special angles, you can still derive the value of your special angles from these graphs itself. So this is a sine graph, right? Sine x. So to show you what I mean, you see when sine is at 90, it corresponds with the value 1. Now I go up to the special angles I show you. See, for this portion right at the end, when sine is 90, the value is 1. 4 root over 2 equals to 2 over 2, which is 1. Something like that. So this way, you can see also when sine is 180, the value is 0 since it is on the x-axis itself. And then now when sine is 270, the value is -1. So on and so forth. So mainly everyone has to just understand your basic sine and cosine graphs. So now for tangent, very rarely they'll ask you to sketch a tangent graph, so don't worry too much about it. Now I'll go through the general features when sketching your graphs when presented to you. So A is your amplitude of your graph, which basically means how much your graph is stretched. So for everyone's understanding, this is my normal sine graph, 1, -1. But let's say now my value of A, they give me a value of 2. Which just means now that my graph is stretched horizontally like that. So, sorry. So now it becomes 2 and -2. So the amplitude of your graph determines how much it is reduced or stretched vertically. And then for everyone to take note, very important, when the value of A is negative, this means that your graph is flipped. So for everyone to understand what I'm saying, this is your normal graph, still sine graph, right? But when the value of A is now negative, your graph will flip about the x-axis. This is your x-axis. So your graph will now flip. So it will be the opposite of the first graph. So this is what I mean. just for everyone to take note, when drawing graphs, be very careful with the plus and minus sign and make sure that you're able to identify it. And then to find your amplitude is your maximum minus your minimum over 2. So to apply this, this is a normal sine graph. My maximum of a sine graph is 1, minimum minus 1. So 1 minus 1. So to find the amplitude, one minus 1 over 2, you get 2 over 2, which is 1. So that's how you find your amplitude. So you all have to make sure you know this equation when you're working with graph questions. This can come in quite handy for you guys. So now we talk about B, which is this portion inside your graphs. So B represents how long it takes for the graph to complete one cycle or one oscillation of the graph. So for example, I draw a sine graph. So let's say the period of a sine graph is 360, which means it has to, from the range 0 to 360, it will complete one cycle. Yeah. But let's say the period of a sine graph is 180 degrees. This means that your graph will is 180, 360. Your graph will complete itself once at 180, just like that. So your graph is now compressed horizontally. So let's say your period of the graph is 180 degrees, but the question asks you to sketch to 360 degrees. This means that you have to draw the graph twice, like that. Okay. Now we talk about the value C. So for C, which is your translation of the graph, in simple terms, it's just how much your graph is moved up or down. So I draw another sine graph again. So also to take note, for O levels especially, your graph will never shift left or right for the value of C. Whenever you see the value of C, it always determines how much more your graph is pushed upwards or downwards. So this is when the normal sine graph now looks like that. The value of the value of C is now 0. But let's say, for example, the value of C is 1. This means that this is 1. My graph is pushed upwards by 1 unit. Like that. So originally, 1, -1. Since my graph is pushed upwards, my maximum point and minimum point. Okay, hold on. My maximum now and minimum also changes. So just like that, because of the value C, my graph is now pushed up. So you can see here, the maximum point initially was 1, and the minimum point was -1. But now the value of C is 1, which means my graph is now pushed up. Now my maximum point is 2, minimum point is 0. Okay. Any questions so far regarding graphs? We'll go through a graph question later as well, so y'all can understand better. Okay. So next, right, for your Trigo identities, these are the main things that you need in Trigo also for you to do well, and for you to understand. You have to understand this well to do the questions lah. So negative identities, which is what I talked earlier about when we were talking about quadrants. So I bring up again the acronym ASTC. ASTC. So you see how in the fourth quadrant, only cosine is positive, which is true right here. Whereas sine and tangent are both negatives. So this applies mainly just for the fourth quadrant, where you have to understand that only cosine is positive, whereas the other two, sine and tangent, are negatives. And then now your supplementary angles. Supplementary angles talk about second quadrant. Same thing as earlier as I mentioned. Sine is positive, whereas cosine and tangent are both negatives. So for your negative identities as well as your supplementary angles, these are just fundamentals, and in a way for you guys to understand what I talked about earlier lah, and also for you guys to apply in your questions when you do it. So these identities, very important. These three identities especially, this will be the identities that you always use or fall back on whenever you have to solve a question or manipulate a question to in your favor so that you can solve it lah. So sine squared plus cosine squared equals 1. 1 plus tangent squared equals to secant squared. 1 plus cotangent squared equals to cosecant squared. This is in your formula booklet, so you can look for it. Don't have to memorize it. Next, for addition formula and your double angle formula. So for your additional your addition formula as well as double angle formula, these are also located in your data booklet, so you don't have to memorize this. So for addition formula, very simple. Sine A plus sine B equals to sine A cosine B plus cosine A sine B. So just to take note, so the sign in here matters because it will determine what your expression becomes. Sine A just for everyone to take note at that. And if it's negative, then of course it will be negative as well. So that's that for your addition formula. Now we go to your double angle formula. Your double angle formula also is in a way just a stepping stone for you guys when you're solving your questions. So maybe sometimes you encounter something that looks a little bit funny, right? And something that you don't recognize. That's where you can go back to your formula sheet and then you can check like, oh, does this match with something that I've learned earlier last time? So just for everyone to take note and be sure, this double angle formula, sine 2a equals to sine a cosine a, is not fixed. Which means, right, I can do sine 4a equals to 2 sine 2a cosine 2a. So you just always realize that the value on the left is twice the amount on the right. So let's say I can do sine a equals to 2 sine half a cosine half a. So this is just additional stuff for you guys to understand and take note. And then for cosine 2a, you have three different equations which you can use. So let's say, for example, next time you are doing a question and you encounter just like cosine 2a, right? Cosine 2a can be converted into any of these three equations. So this basically just means that all four of these equations can be interswapped and used. Yeah. And lastly, you have your tangent 2a equals to 2 tangent a over 1 minus tangent squared a. So for the last one, right, half angle formula, this can be derived from your double angle formula. This is not in your data booklet. I repeat, it's not, but you can derive it from here. So just to show you what I mean, I just use any of the I just use the equation cosine 2a equals to, I'm using the last one here, 1 minus 2 sine squared. So now I want to make sine the subject of the formula, right? So I move 2 sine squared a over then 1 minus cosine 2a divided by 2 on both sides. And now I square root it. Plus minus, since square root can be both negative or positive. Like that. So you can see what I mean. This can be derived from this. So nothing to worry about actually. This is all just part of manipulating the question to fit what you need to do. Okay, lastly would be your R formula. So for R formula, usually to identify how or when to use your R formula, you would get like an like a shape, a very weird shape or something, and then you have to convert it into a specific form like that. So the question will ask you, convert it into this specific form, and that's when you know you have to implement your R formula. So for your R formula, mainly you have to just memorize this. Mainly you have to just memorize this equation, and it's very specific. So you can see the first trigonometric ratio in front matters because it will determine what you write for your R formula. So at the front you have sine, therefore your R formula will be in sine form. Whereas when you have cosine in front, you have cosine as your R formula. So this is just something for you to take note of and just be sure what the question wants, what form the question wants you to use. And to find the value, now I move on. Now to find the value of R, very simple. Just do R equals to square root a squared plus b squared. So these values will be provided to you. Nothing to worry about. And then now, to find the value of alpha, in this case here is written as a, so don't be confused. It means alpha. It will be the value of b over a. So b over a. So that's why I tell you the way you write your R formula really matters. Because let's say this is 4, this is 3. You're working, the question asks you for sine, right? But you accidentally put 3 cosine theta. So the question asks for sine, but you put cosine at the front. Now your value of b becomes 4. And then the value of a becomes 3, which is wrong because you needed to put 3 over 4. Yeah. So this is something for everyone to just take note and be careful about when the question asks you. Okay, so I've gone through the notes quite a bit. I think now we can go through some questions and for everyone to try also. So now everyone can get their worksheets out. I'll give you all some time and then we'll go through it in a minute. Okay. Now I'll go through the first question. The simple question which comes out in the exam often, and these are the type of questions where you have to get it correct because they're giving you 3 marks. So on your end, make sure you get the 4 marks or the 5 marks that this question is usually allocated. So to start off, okay, take note also, the question is in degrees and okay. Hold on. Let me sort this. Hold on. Okay, give me a second. I will restart my iPad. Okay, sorry. Can y'all try to attempt the question first? I will try to sort my iPad out. I'll give y'all like 5 minutes to 5 to 7 minutes to try the question. After that, I will go through it with everyone. Okay. Sorry about that. I will now go through the question, the first question. So now you take note, questions in degrees. So later on when you find your angles, make sure that your angle is in degrees as well. So the first thing I will do, 5 tangent plus 7 plus secant y. So I want everyone to understand that the concept here now that we're trying to use is your identities. Right here. So this, sorry, since tangent, sorry, this one. So since tangent squared is the subject of formula, and you have a secant y here, you want to change everything to make it a bit easier for you. I would do 5 secant y squared minus 1 plus 7 goes to 11 secant y. Like that, I'll just expand my equation. 5 y squared, sorry, minus 5 plus 7 equals to 11 secant y. Now I'll move everything all over to the left side as well as simplify the equation. Minus 11 secant y plus 2. Okay, simple stuff. Now this is just your basics, your quadratic formula. You have sine secant, sorry, okay, so you have secant squared and then you have secant. So this is also the same as saying 5a squared minus 11a plus 2. So this is the same thing. So now I'll do 5, 2, 5 secant y, then I put 2 here because I want to make it 10, negative on both. So I get negative secant y minus 10 secant y, just like that. 5 secant y minus 1 secant y minus 2 equals to 0. Okay, so I would have 5 secant y minus 1 equals to 0, or secant y minus 2 equals to 0. So now I solve accordingly. I would have secant y equals to 1 over 5, or secant y equals to 2. So take note, right? Secant y is 1 over cosine. So what you need to do, you need to flip the equation. What this means is that when you flip the left side, you also have to flip the right side. So you have cosine y equals to 5, cosine y equals to half. Now, remember when I talked earlier about the maximum and the minimum of cosine and sine? I said that the maximum value of cosine is 1. So now we have the value 5, right? It's not possible for us to solve it. All we need to do, you just need to reject your answer. As for cosine y equals to half, it is within the range, and therefore you can solve it. So now I'll find my basic angle first, which is alpha. So just find the basic angle is 60 degrees, right? So now they give me the range from 0 to 360. So if I bring out the quadrants which I spoke about earlier, A, S, T, C, the values of which cosine is positive is in the first quadrant as well as the fourth quadrant. So to find the values of y, I would have the first quadrant, which is 60, and the last quadrant, which is 360 minus 60 degrees, goes to 300. So the values in between 0 and 360 would be 60 as well as 300. Okay, so for Daya, you ask how do you know what to reject, right? So I bring you back earlier to the features of your graph. So the maximum value which sine can be is 1, and the minimum would be -1. So this means that any value from -1 all the way until 1 is possible to figure out. Whereas earlier on, we have the value 5, right? 5 is outside the range of -1 to 1. So like that, I'll reject 5, I'll reject 4, I'll reject 3, I'll reject 2. But if I get 1, I don't have to reject it. Same as negative. And also you can use decimals. So any value 0 0.1, 0 0.2, 0 0.3, also possible to be solved because it's within your range of 1 to -1. So you just have to remember the maximum value that sine can take and cosine can take, which is 1, as well as the minimum, which is -1. So in this case, I have 5 here. I would reject, and then I'll do the other part with I have, which is here. Because half is within the range -1 to 1, therefore I can use it. Okay, good. So now I run through this question very quickly with everyone, since we already did the first question. Okay, now you see we have cosine 2x, which is a bit unfamiliar with everybody. So you can go to your notes you can see earlier, which I mentioned, cosine 2a equals to all these three equations, right? So now we have to think also, which of the three equations would I use? So the question already has a sign for me. So this gives me a clue that if I want to make the equation in a way nice for myself, I will want to make everything sign. So because of that, I would choose this. So I'll write the question. Take note as well, this is in pi, which means radian mode. So this cosine 2x will be changed. 1 minus 2 sine x squared plus sine 2 sine x. Okay, expand my equation for okay. Now I'm shift everything to the left. Sine squared plus 2 sine x plus 6. Now I simplify everything to make it a bit easier for myself. Minus 4. So everything divided by 2. Minus 4 sine square x plus sine square x plus 3. Okay. And I make my first number positive. So I'll multiply everything by -1. 4 sine x squared minus sine x minus 3. Okay, same thing as just now. So all these workings have to be shown when you are doing your exams. Okay, so now put 3 on, put a minus here. 3 sine x minus 4 sine x. And then 4, 3 x minus 1. Okay. Equals 0, or sine x minus 1 equals 0. So now I want to make sine x the subject of formula. Or sine x equals to 1. Okay, so same thing as just now. I mentioned you can accept. Now you want to see what you want to reject or accept, right? If you look at these two values, they are both within -1 to 1. So you accept both. But you can see that for this, it is -3/4. What this means that is if you look at your quadrants, okay, A, S, T, C, right? So from what we learned earlier, A, all the angles are positive. For the second quadrant, only sine is positive. But since now the question shows us that, or our workings show us that sine is negative, this means that we have to work with the third and the fourth quadrant. Okay, any questions so far? Okay, no questions, I'll continue. So first thing we do, always do, find your basic angle. Don't care if there's a negative or positive value, your basic angle will always just be the value that is presented to you. In this case, 3/4. So I do alpha equals to sine inverse 3/4. And then I use my calculator. Make sure your calculator is set in radian mode because of the question. And sine inverse 3/4, I will get 0.8480. So usually when I'm still doing my workings, I will leave my workings in 4 or 5 decimal places. Only when I write my answer, then I will write it in 3 significant figures. So to find the value of x now, I know that I have to use the third as well as the fourth quadrant to find. So to find the value of the third quadrant, I would do pi plus 0.84. Then for my fourth quadrant, it would be 2 pi minus 0.8. So just like that, I will get 3.99 and 5.44 respectively. Okay, so now back to this. For the other working, it would be by using special angles, x will be pi/2 and then 1.57. Any questions so far? Okay, if not, I will carry on. Okay, I'll give everyone 5 minutes just to attempt the next question, and I'll go through it at 4:30. So just try out this question. This also involves you working with the identities. Okay, so someone asked how I get pi/2. So I'll go back to this. So remember earlier, I thought about your graphs, correct? So what we had just now, sine x equals to 1. And if you look at the sine graph, when y equals to 1, your value of x is 90. So that's how you get pi/2, because pi/2 is also the same as, okay, wait, sorry, pi/2 is the same as 180/2, which is 90. But because your question is in radian, therefore is pi/2. Anything you can also refer to the special angles, which I have mentioned about. So right here. Yeah, okay. Okay. Someone asked for the answers for the first question. Okay, I zoom out like that. You can take a screenshot. I'd like everyone to try the next question. At 4:30, I'll go through it. Okay, 4:30. I'll go through this question very quickly. I hope you all got your answer. If not, it's okay. Just look at my answer and then see what you missed out. Okay, so so the question says A and B are acute angles such that sine A minus B equals to 3/8. Sine A cosine B equals to 5/8. So without evaluating the angles A and B. So by the looks of this question, you can tell what they would want you to use. In this case, it would be the addition formula right here. Okay, so now part 1. So I write what they give me. Sine A minus B goes to 3/8. At the same time, I also just expand this equation. I will get sine A cos B minus sine A sine B. Just like that. Then since sine A minus B equals to 3 over 8, replace that, equals to, don't forget that they gave us the value of sine A cosine B, which is 5 over 8 minus, yeah, so just like that, I can easily find the value of cosine A sine B. Cosine A sine B equals to 5 over 8 minus 3 over 8, 2 over 8, 1/4. Done. Okay. And for the next part, find the value of cotangent B over cotangent A. So I'll do this slowly so that everyone can understand. So for cotangent B, it would be cosine B over sine A, sine B divided by, now cotangent A, which is cos B cosine A sine A. So you'll get it for now. Okay. And then next, just continue with this. Now I would flip the divisor. So I will multiply sine A over sine A. Okay. Now I get cosine B sine A, sine B cos A. And the thing about it is, earlier in the question, they asked me to find value of cosine A sine B. Right here also, cosine A sine B. And then they gave me sine A cosine B, sine A cosine B. Therefore, 5 over 8 over 1/4. And I get 5 over 2. Okay. Any questions so far? Okay. No questions. Move on to proofs. So proofs are also part of Trigo, where I find this quite fun. It's just manipulating and using different identities that you have learned to make the left-hand side and the right-hand side the same. So I'll go through this. First, let me break everything down for everyone. So cotangent x minus tangent x, cosecant x, secant x minus 2 tangent x. So just for everyone to have a sense of idea what this whole thing means, it basically means 1 over sine multiplied by 1 over cosine. And then you have a minus 2 tangent x. So it's 1, you can just combine it. 2 tangent x. So I want to make the left-hand side the same as the right-hand side. So these are just workings that you can do during your exam to make your life a little bit easier. So you don't have to show this. Okay? So I just write left-hand side cotangent x minus tangent x. And I carry on working from here. So what I would first do, split it up, break it down so that it's easier for me to understand. Okay. So now what I would do, cross multiply so that I can combine this fraction together. So this cosine squared x minus sine squared x over sine x cosine x. Okay. So far, everything okay? No questions, I'll carry on. So now you see cosine x squared and sine x squared, right? So this is the part where you have to be a bit more proactive and realize that this is actually one of the identities that we've learned. So now I see on the right hand side, I'm trying to get to 1 minus 2 tangent x. Sorry, 1 over sine x cosine x minus 2 tangent x, right? So I would just, so this is what we have, which can be manipulated into the others as well. So I'm just going to change this into 1 minus 2 sine squared x over sine x cosine x. Now there's a very specific reason why I did this. You will see it. If I carry on, I split the fraction up. 1 minus sine x cosine x minus 2 sine squared over sine x cosine x. So now you see I already have the first part right here. So now it's just the second part, right? All I have to do, simplify the equation. So sine cancel out 1. I'll get 2 tangent x. And just like that, I've proven. And then of course I'll write cosecant x secant x minus 2 tangent x. So just like that, I've proven how you can do this question. So actually, right, if you want, okay, yeah, so I will show you how you do it with right hand side. So from the right hand side, same thing. I'll just make it into this fraction first. Sine x cosine x minus 2 sine x over cosine. Then what I will do, just combine it. 1 minus 2 sine x squared over sine x cosine x. And then now earlier from where I mentioned, we can now use the first identity that we learned. So we get minus sine x plus cosine square x. And then sine x over cosine x plus cosine x over sine x. Now, this part may be a bit confusing, but all I did, I just separated them into their own fractions. So sine square x over sine x cosine x plus that. So that's how you can see it. And then now I can prove cosine over cosine, then plus. Okay. So this is how you solve the equation from the right hand side. So I've given you your left and right hand. So this is a very good question. I don't think many of y'all have seen this. So good for y'all to just understand and just remember in case this comes out in your exams, y'all know what to do. Okay. So for the next question, I will skip it for now. We will go through this during our weekly lessons. Anyone who attempts this question and is not sure how to do it, you can drop me a text. I will gladly help you with it. But I just want to give you a clue for this. Just take note. Sine 2x plus x. So I will start you all off with this. This is the clue I'm giving you all. From there, I hope you'll work out and get the right hand side. Okay? Okay. So I'll go through graphs with everyone very quickly. So given that, so they give you equation of the graph, a general formula. Given that the y-intercept of the graph is 1, find the value of p. So this just means when x equals 0, y equals to 1. Simple as that. So you get 1 equals p plus 2 cosine q. And then, so cosine 0 is 1. So I'll get, so it'll just be like that. And the value of p would be 1 minus 2, negative 1. Just like that. Okay? Yx equals 0. So whenever you have a y-intercept or x-intercept, it means just for you to see. So a y-intercept just means when the line intersects your graph at the y-axis, right? So this is your y-axis. This is your y-axis. This is your x. Intercept the graph is 1. So this is 1, right? It also means that the line intersects like that. So there's no possible way whereby x is involved in anything. So therefore, x equals to 0 because there is no value for x. Same thing applies when they tell you, given that the x-intercept of the graph is of such value, it basically means that y equals to 0 because now they tell you somewhere along here, your graph is being intercepted, the line will look like that. So y would be equal to 0. Okay. So hope I have answered your question. Okay. So now, given that the period is pi over 3 radians, find the value of q. So remember earlier on, I told everybody about period equals to 2 pi over b, right? But in this case now, it's q. So just take note, q. I'll just replace it with q. So they tell me the value of period, which is pi over 3. All I need to do is equate it to each other. And then I will get q equals to 6. Okay, so next question. I will first fill up all the details that I have. So y equals to 2 cosine 6x minus 1. Okay, so how do we start with drawing a graph? You have to also see the question asks for interval of 0 to pi over 2. And they've told me that the period of this graph that I'm drawing now is pi over 3. So just for everyone to take note, since, let's say, okay, so I'll just I'll label the x-axis first. Since I know that the period is pi over 3, which means the graph will finish one cycle at pi over 3. Pi over 3, right? So now I just fill in accordingly all the other points which are needed. So to find the midpoint for my x-axis, it will be pi over 3 plus 0, and then I'll divide it by 2, which gives me midpoint of pi over 6. Okay, so now I just do it accordingly to find the other points of my graph. I do 0 plus pi over 6 divided by 2, I get pi over 12. And I get pi over 4. So take note of this minus 1. It tells me that my graph has been pushed down by 1 unit, right? Okay, so it's a bit messy. I will touch it up in a bit. So minus 1, right? And then now I look at my equation, I see I have value of a, which is 2. So it tells me that the graph stretches for 2 units. So if I go upwards, it will be 1, because from -1, I move up 1 unit, 0, another unit, 1. Now to find my minimum value, I move down 2 units, it will be -3, just like that. So after I've found my maximum and my minimum, as well as, okay, I'll just quickly, so there's pi over 3, pi over 6, pi over 12 and pi over 4. Okay, so now I will start drawing my cosine graph. So just like that. Okay, so I've drawn up to pi over 3, but the question wants it up to pi over 2. So which means I have to extend my graph even more. Pi over 2, right? Then I have to find the middle point, which would be 5 pi over 12. And I continue drawing the graph until pi over 2. So I'll draw one more oscillation of the graph down, but I stop at pi over 2, so I don't continue anymore. Okay. Question 3. Okay, don't worry about the answers. I will send it out to you guys later on after this lesson. Okay. Okay. Now let's do this last question. So first, I have to find the principal values of y. Very simple. All I have to do, just carry on with what I have done earlier as well. Done y plus tangent y minus 6. And then 2 tangent y. Now get 3, 2 minus 3 tangent y, 4 tangent y. Okay, now I'll do 2 tangent y plus 2 equals 0, and 2 tangent y minus 3 equals 0, or tangent y plus 2 equals 0. So now tangent y goes to 3 over 2, tangent y goes to negative 2. Okay, so now for tangents, right? Remember I said how there is no limit for tangent. There is no maximum, no minimum. So I don't have to care what the value of it is. I can still equate it. So now I will carry on to find my basic angle first. Tangent inverse of 3 over 2. I will get 0.927. And then now I run off to 3 significant figures. 3SF. As for the other one, remember how I said don't bother whether it's a negative or positive if you're finding the basic angle? Same thing. And I will get 1.107, 1.11, 3SF. Okay. So just like that, I have found my 2 principal values of y, which also basically means your basic angle. Okay, now on to the next question. height hm above the ground of a carriage on a carnival Ferris wheel is modeled by the equation h minus 7 minus 5 cosine 8t, where t is the time in minutes after the wheel starts moving. So first they ask to state the initial height of the carriage above the ground, and then find the greatest height reached. And then calculate the duration of time when the carriage is 9 meters above the ground. Okay, so there's many things going on right now. How do you know whether to calculate in radians or degrees? Okay, so for this one, question has stated in radians. Okay, but if they are not, if the question is not clear, usually they will put something like that or something like that. So this is for degrees, this is for radians. So just for you to take note. Okay. So now I'm going to do the next part. State the initial height of the carriage above the ground. So part B, h equals to 7 minus 5 cosine 8 theta. Okay, I want everyone to understand, right? Actually, there's not much thinking that you have to do for this question because they said the initial height. So when they talk about initial and when they tell you that t is the time in minutes after the wheel starts moving, right? So at the initial, when your wheel has not even moved yet, your time would be 0. So all I need to do when t equals 0, sine 0, and I will get 7 minus 5, 2. So this, oops, this is the initial height of my Ferris wheel because my Ferris wheel has not even moved yet, so the time would be 0. Okay. Next part, the greatest height reached by the carriage. So just for everyone to visualize, I'll just draw it at the side right here. I want everyone to take note of the -5 of this general equation. So it's 5 cosine 8t plus 7. So this basically means, right, that, okay, it's a bit squeezy. My Ferris wheel, because of the value c, 7, and then it goes 5 units down because of the amplitude, V2, then 12. So it's a bit congested, right? So I'll just draw my graph like that. Just a simple representation for everyone to see. So actually, it's quite easy after you have drawn your graph and you have manipulated your general equation. You can tell that at this point, this is your maximum, and maximum equals to 12, just like that. Because this is the center of your graph, which is 7 right here. And then remember I said earlier about amplitude tells you how much your graph stretches, right? So 5 units up from 12, sorry, 5 units up from 7 would be 12. So part B, part 2. would be maximum. It will be 7 plus 5, 12 meters. That's my maximum height. Okay. And so done. Calculate the duration of time when the carriage is 9 meters above the ground. Okay, so now I want everyone to visualize. This is the last question that we'll be doing. The other questions will be run through in our weekly classes. So after this, we'll be done. So now they tell me that when the carriage is 9 meters, right? So let me just draw the graph again for everyone to see. So this is how my graph currently looks. Seven to 12, right? So now they tell me that my height is 9 meters above the ground. So just anywhere along the graph, 9 meters, and I draw a straight line through. So can you see that it intersects this graph at 2 points to give me two x values, x1 and x2, right? So very simple. All we need to do, just when h equals 9, I get 7 minus 5 cosine 8. Okay. Cosine 8t goes to 9. Then from there, I try to solve question. I get 7 minus 9 equals to 5 cosine 8t. Then I get minus 2, 5 cosine 8t. And then now cosine 8t equals to 2, negative 2 over 5. So just for everyone to take note, all STC, since my value is negative, I am looking at the second and third quadrant. I'll first find my basic angle, cosine inverse, 2 over 5, which would give me 1.1592, right? Just a few, I wouldn't put in 3 significant figures yet. I'll just leave it in 4 to 5 decimal places. Then now, they ask me to calculate the duration of time. So the duration of time would very simply just be x2 minus x1. So now 8t equals to, since cosine is negative, we're looking at the second and third quadrant, it would be pi minus alpha, as well as pi plus alpha. Okay, so we'll do the calculations for that first. You get 1.9823, comma 4.03. So these are two values that I'm working with. Now I'll get the value of t. What I need to do, just divide by 8. 477. And 375. Okay, so now I have the two values of t, right? Which is also my x1 and x2. Since time can never be negative, it will always be the bigger value minus the smaller value to get the duration. So, oops. Okay. Okay. So, anyways, give me a second. Okay. Duration equals to hold on. Okay, my thing is not working, but very simply, just take 0.5375 minus 0.2477 and you would get, let's see if I can, okay, you should get 0. Okay, never mind. You should get 0.2898 rounded off 0.290 minutes. Three significant figures. Okay, so I have solved the last question. Oh, okay. So 0. minutes. So this is what you should get. Okay. Any questions before I end off? Any remaining all the remaining questions that were not done will be covered if you sign up for our AMAth classes, and then I'll go through it with you then. Okay. Okay. So anyways, oh, okay, there's a question. How did you get pi over 12? Can I ask which question you are referring to? 资源. This is it? Okay, I get what you mean. Okay, so to get pi over 12, very simple. All I have, do you realize that all of this, between this, they're all the same. So what I've done to find the middle point of this, I've just taken this entire thing and then I have divided it by 2. So to find the middle part, so I take 0 plus pi over 6, and then divide it by 2, and then I'll get pi over 12. Understand? Okay, so I give you like a easier way for everyone to understand. Let's say my graph is until 360 degrees, right? All I do to find the midpoint, I just divide it by 2. I get 180, get 90, and 270. Because for this portion, I just take 180, divide by 2 again to get 90, and then to get 270, I take 180 plus 360, divide by 2. So very same logic applies here. Instead of working with 360, I'm now doing it with pi over 3. And that's how I get the subsequent x values. Okay? So how to get the final answer from T? Okay. Don't worry too much about the... Do we need to draw the graph to answer part B of the carriage question? No, you do not have to. You do not have to. I am only drawing the graph so that it is easier for everyone to see how to solve the question better. If you don't need to draw the graph to solve it, you can do so. Sure, no point of... Four, five. Yes, Daniel, you are correct. So, just I will send out the correct workings for all of these. Don't worry too much about it. I'll send it to the group chat. And then for now, if you guys are interested, you can scan the QR code, which I'm flashing on right now. And then you can sign up for our weekly classes. Yeah, so don't worry too much about about the answers. I will be sending them out into our group chat, and then y'all can see from there. Okay, so at 5:20, I will end the call for everyone. If you want, you are welcomed to leave the call right now if you have scanned the QR code. Yeah. If not, thank you, everybody. Okay, goodbye everybody. I will end the stream as well as the call now.